In this video, we will consider this equation, which contains parameter a, which is a constant. The goal is to find the value of a when this equation has a single solution. To do this, we consider first the various cases when this equation has a different number of solutions. First, let's consider simplest case when a equal to 0. In this case, equation has the following form. We move x squared to the right, and we consider two functions, one for the left-hand side of this equation and another for the right-hand side of this equation. When left-hand side equal to right-hand side, this provides the solution. Let's do graphical analysis. We plot both these functions together. First, we start with this function, which is parabola of this form, and the top of the parabola is at point 3 in vertical direction. Then we plot the second function to x. This is this line, and we see that these two curves intersect at 2 points, which correspond to roots of equation x1 and x2. So we conclude that at a equals 0, equation has 2 roots. Now we consider the case of positive a. In this case, equation will have the original form. Again, we move x squared to the right and introduce two functions, one for the left-hand side and right-hand side as the second function. We plot first parabola. It has the previous shape. And first we plot the function to power x and take into account that 2 to power x minus a, the plot of this function, can be obtained by displacement of this curve to the right at distance equal a. Again, we see that this curve intersects the parabola in 2 points. It means that this equation for positive a has 2 roots. The last case which we should consider is case of negative a. We repeat the procedure which we used previously. Again, we have two functions, but now a is negative. We plot first the parabola, then we plot the function 2 to power x, and we take into account that at negative a, the plot of this function we can get from this curve by displacing it to the left on the value a, absolute value of a. Here we see that for small displacements the equation will have 2 roots. For large a, we have no roots, so no points of intersection. And there is a specific case when the curve of function 2 to x minus a and the parabola has the single common point. In this case, the equation has 1 root. So we come to conclusion that at negative a exists either 2 or 1 or no roots. Now we consider the case of the single solution of this equation. What we have in this case? We have in this case that these two curves has a single point of intersection, and at this point they have the common tangent. We denote the x-coordinate of point of intersection as x0, and we try to find equations which involve x0 and a for this point. First of all, we note that at this point, these two functions has the same value, and for this reason, we have first equation for x0 and a. The second equation we will obtain taking into account that these two curves have the same tangent at this point. So we can calculate the slope of this tangent using the curve for first function and for second, and equate these two slopes. We start with this function, and the slope of this function, which is equal to derivative, we can represent in this form. And from another hand, we can find the slope using equation of this parabola, and this is just negative 2x. The slopes are the same, so this part and this part of these two equations are equal. So we can write the second equation for x0 and a. Solving these two equations, we will find both parameters. Now we consider this system and try to find x and a from this system. For simplicity, I don't write subscript 0 at x. Let's first consider the possible values of x. Left-hand side of this equation is positive, so it means that a right-hand side also should be positive. And from this inequality, we can find the range for x between negative square root of 3 to positive square root of 3. Now we look at equation 2, and we see that the left-hand side of this equation is always positive, so a right-hand side should be also positive. From here, we can conclude that x should be negative. Considering these two inequalities, we conclude that possible values of x are restricted to this interval between minus square root of 3 and 0, or taking into account the value of square root, x is between these two numbers. Now return to the system. We see here 2x minus a and here 2x minus a, so we can replace this with 3 minus x squared, and we get the equation which contains only x. We divide over ln 2, rearrange the terms, and we have quadratic equation for x. Now we will solve this equation. We will use the formula for quadratic equation, which has this form, and in this case the two solutions for x are given by this formula. Comparing this equation and this, we see that here b equal negative 1 over ln 2, c equal negative 3, and using these values in this formula, we will get two solutions of this equation. First solution with plus provides x1 equal 3.697, and this solution is outside of the range of possible values of x, so it should be cancelled. Second solution is with sign minus here. It gives us the value x2, which is inside of this range. And finally, we conclude that x0 is equal negative 0.8 and something. After this, we can find a. using equation 1 and value of x0 which we found. We take natural logarithm of both sides of this equation. We use the property of logarithm and rewrite this equation in this form. From here, dividing over ln 2, we can find x minus a. And finally, we have equation for a. We use here, instead of x, we use x0. And we get for a this value. This solves the problem. So we can make a conclusion. Equation which we considered has at a greater than a0 two roots, at a equal a0 one root, and at a less than a0 no roots. If you like this video, you may want to hit like button, leave a comment, and subscribe for my channel.